Welcome everyone to our fourth and final webinar in the series. You can continue to follow Hermione across the Atlantic and see the weather data being uploaded daily during her voyage 2015 at seaformation.com. That's SEA formation.com. Today we will be talking about propulsion. How did ships move in the 18th century, and what innovations have allowed today's Hermione to keep to a much tighter schedule than the original? For those who are hearing about the ship for the first time, we invite you to check out our website, seaformation.com, where we explain it in greater detail. You are about to board a full-scale, authentic replica of the original Hermione, which was built in 1779 to carry the Marquis de Lafayette with the news of King Louis XVI's support of the U.S. colonies. Today, Hermione is heading to the United States in celebration of Franco-American friendship, which, it can be argued, started with Lafayette and Washington. One of Lafayette's mottos is "Que non," meaning "why not?" And indeed, why not use this incredible story of defying the odds and building this ship to launch a new way of thinking about learning? These webinars are designed to start conversations that can be had between classrooms on both sides of the pond, as we sometimes refer to the Atlantic. We encourage you to continue to investigate and learn through our website. If you do, please take a minute to leave us your contact info, and we will publish a list of participating schools so that a shared curriculum might be created for the next school year. Excuse me. On with today's presentation. Today we have Laurent DaRold in France. Laurent's company, Yacht Concepts, played a key role in all the technical aspects of the ship's construction, including the engines. We will also hopefully have Sven Tullberg joining us in the US. Sven has a passion for sailmaking, especially those that are used aboard a ship like the Hermione. Right now, I'd like to welcome both of you, and Laurent, if you could explain just briefly your role with the ship, that would be wonderful.
Okay, nice to speak to you. Laurent DaRold is speaking. I've been in charge of the full project management of the rebuilding of Hermione from 2007 until the end of construction. So that means around 2/3 of the construction, and especially all the riggings and the sails and all the interior fittings and all the modern equipments we have fit in the ship, including engines and electricity and so on.
Wonderful, thank you. And Sven, can you hear me yet? Nope. All right, well, we're still waiting on Sven, but hopefully he will join us too. We are also hoping to be joined in a few minutes by Anne Renaud, the sailmaker who is aboard, as well as Jens Langert, the head rigger from aboard Hermione. Before we start answering questions that have already been coming in from our website and from Twitter at C__formation, let's watch a short video describing today's topic.
Welcome to our fourth and final webinar on propulsion, the story of sails and auxiliaries or engines. In the 18th century, they did not have an engine aboard, but they did have this. So the Hermione, just like the traditional one, the original one, has 17 sails, and they cover a surface area of 2,200 meters squared, which is, for us that work in feet, it's 23,680 square feet, which is huge. We're talking about several basketball courts of sails, and to manipulate them, it takes a lot of sailors. Back in the day, the Hermione was powered or was handled by anywhere from 240 to 300 men, because they had not only to sail the ship, they also had to manage the cannons. Today, we are 80 aboard, and at any one time, there'll only be 20 to 22 sailors handling the sails. And the amazing thing is that because of the miles and miles of rope that need to be handled and the weight of these sails, it can take well over an hour. And in fact, the best time we've had is about an hour and 15 minutes to set all the sails at once. Once the sails are set, we're sailing along, one of the big misconceptions that many people have is that because it's a square sail, that the only way the boat moves forward is if the wind pushes the boat forward. And that's true if the wind is directly behind us. In fact, square sails do work by pushing the boat in that case. But most of the time, the wind is coming across the ship or actually from in front of the ship. And in that case, the sails need to be turned to allow the wind to blow across the sail, not from behind it. And in fact, it's just like the wing of an airplane. The sail pulls the boat forward because there's a draft in front of the sail. There's a low pressure in front of the sail and a high pressure in the back. That actually sucks the sail forward, which pulls the ship. There's a demonstration I can do for you. You can try this on your own. Just take a simple piece of paper and you blow as hard as you can over the top of it. You're going to see my breath lift the sail. If I blow hard enough. There you go. And that's the lift that causes the ship to move forward most of the time. So clearly the Hermione is sailing a long distance and using traditional cloth-made sails, linen sails. She's putting those sails to a real test. And as we sail across, there's going to be times when they need to be maintained, and that's why we have a sailmaker aboard. Anne is constantly watching the sails and calling on sailors to help her restitch sails as we make our way across. In addition to that, she's also teaching us how to make a sail while we sail. So we're actually in the process of putting together by hand a replacement sail and teaching all of the sailors how to stitch and the functionalities of that sail so that we all learn while we make this trip. Once we're done using the sails, there are two ways to stow them. The first part is called carguing, which is to just bring up the bottom of the sail to take the wind out of it, essentially. But then when we're really done, we need to furl it completely. We need to put it up against the yardarm, and that's what my co-guerriers are doing up above me. So obviously we love sailing, but that's not always possible. Sometimes there's no wind or it's coming from the wrong direction. And in that case, the Hermione, being a modern ship, has an advantage over the 18th century. She's powered. She's got auxiliaries. The way it works, these two generators, 400 kilowatt generators, power two electric engines that we're going to see later at the aft end of the ship. In the meantime, though, the engine that you're hearing right now has nothing to do with propulsion. It's actually feeding the ship electrically to keep the refrigerators, the washing machines, the lights on board all functioning. That's what you're hearing right now. So coming out of the engine room, we're now in a space where things are maintained. And this is the chief mechanic's space, Philippe, who's not here right now. This is where he keeps all the spare parts and where the pumps are located that circulate the water to cool the engines, but also to provide water for the crew. And I want to show you something kind of really cool about this ship that we're going to go over here to look at. So back here is where they turn salt water into fresh water. This is called a reverse osmosis machine. Fancy name for basically taking seawater and processing it under pressure to pull all the salt out of it. And it ends up giving us fresh water. But there's still also bacteria that can be in it. And so this boat has something that I've never seen before, but it's really fancy. It's an ultraviolet device. All the water passes through this silver tube back here, is exposed to UV rays, which purify the water one step further. So this system gives us an endless supply of fresh water, but of course, we're all sailors at our origins, and we're going to be really careful not to abuse that because it takes energy to make this water. I'm conscious of that. Follow me. I'm going to stop here just 1 minute because we're having going through here. You might recognize this. It's called a kitchen, which might be very strange to find it in the bilge of a boat, but here we are. And with 80 hungry sailors, there's a lot of activity. Right now it's nighttime. Everyone's resting for tomorrow when we leave. But you can see that there are ovens, place the dishwashers, and around the corner here there's a number of large freezers to keep all our food frozen that needs to be. So continuing our way back through the ship, I want to stop here for a second. This is called the campus, or in English it would be the pantry, and it's fully stocked today, just today, for our long trip across the Atlantic. I want to show you that we've got washers and dryers to keep everything clean, but also just the amazing amount of food that it takes to feed 80 people while we make our way to the engines. And so we finally made it. We're in the engine room. We've done the entire length of the ship, and we are now in the location where these electric pods, what you're seeing is the motor itself, and through the hull, which is right here, it goes out to this large cylinder, which has a huge propeller in it. And we've got two of them, one on either side, and the pods themselves actually rotate. You saw the picture on the website. They rotate left and right to push the boat one way or the other, or stay straight to push it forward. Pretty amazing. So those are the engines, and now we're in a room just above the engines called the descent valve, which is a space that's shared by the doctor, as well as the place where the sailmaker does all her repairs on the sails. And that's our unit on propulsion. I hope you've enjoyed it. I hope you've learned something. And it's also our last webinar of the series, so it's been a pleasure being with you on this trip. We look forward to seeing you at one of the stops along the route on the U.S. coast. Take care, everybody.
Let's get started with the questions, and hopefully the ship will dial in soon and we can direct our attention to them. Our first question is regarding the engines, Laurent. Sylvie in Rochefort wonders if the engines are powerful enough to move the ship, or are they just for maneuvering to dock?
Well, the engines are designed to be able for maneuvering, of course. The main purpose is for security. I mean, the dimensions of the engines has been calculated to be able to go front wind or part front wind with around 40 knots in icy conditions. I mean, the idea is to be able to save the boat from a coast if the wind is blowing the ship to the coast. So that's the main dimension. So of course, the two engines are able to push the ship enough when there is no wind or not enough wind to sail.
Okay. And I'm not sure if you've had any contact from the ship. I haven't personally asked this question yet. Do you know how often they were planning to use the engines, or was it just if they had to, for security, they would bring them on, or to keep the pacing of the trip, they would bring them on?
I can give you two, 3 figures. For example, during the sea trials we have done in September and October last year, we have sailed around 80% of the time with the sails, so only 20% of the time under engine. So it completely depends on the wind you have at the moment. During the crossing, I haven't all the statistics, but I think starting from Las Palmas 2 weeks ago, they have sailed, I think they have been under engine, I think 1 or 2 days maximum.
Okay.
The point which is clear is that they do not have enough fuel to make all the cross under engines. It's a real sailing boat. I mean, the engine is just there to be able for security. There is a problem somewhere, and also if you have a long time without wind, that you have to cross a certain type of weather with no wind, you use engine for 1 or 2 days, and so you can start again with the sails.
There's a related question here from Tom in Philadelphia. He wants to know how much fuel the generators use when they are powering the motors, and how much fuel the ship has to carry. Basically, how far could they sail under engine power if they had to?
Mm-hmm. the fuel capacity of the ship is around 20. It's in liter, 25,000 liter. I don't have the figure in gallons, but it might be around 500 gallons, something like that. So the ship, when the ship is under engines power, it's around 100 liter per hour.
Okay, so that's fairly significant.
Yes, that's right. Yes. It's quite a huge ship. I mean, it's 1,000 tons, so you need you need power to push the ship, even if the system is very efficient and that you need not so much power. For example, to push the ship at around 6 to 5 to 7 knots, you need around 200 kilowatts to push the ship.
That's a lot of power.
Mm-hmm.
We have a question about the choice of electric engines over diesel. Shay Seaborn is wondering what the main advantages of electric engines are, or why they were chosen in this instance.
That's a good question. In fact, there are several things to take in consideration. First of all, is that in such a ship, such a huge ship, you need permanently power to electric power for as Mark was explained before. You need electric power for the security and also for the life on board. I mean, for the kitchen, for the fridge, for the water maker, for the security, for the electronics, for the pump, and so on. You need quite a huge capacity of electricity. That means around during the night the consumption is around 15 to 20 kilowatts, and during the day it's between 50 to 60 kilowatts all the time during. You see. So you need electric power in order to be able to live and for the security of the ship. That's the first point. The second point is that it's a bit easy to say that the ship hasn't been designed in 1779. She hasn't been designed to install an engine with a propeller at the end, with a shaft. So it's very complicated in such a ship to install such an engine. It's possible, but it's quite complicated. Especially the carpentry to manage to install such an engine is quite complicated. So we have tried to find a better solution, which is to have a shaft which is perpendicular of the hull. That means a direct hole that you have seen on the video, a direct hole from the top to the bottom of the hull. And so when you do that, you just have a very small place on the top to put an electric engines. At the end, we have found a much better solution for technical reason and also for financial reason in using an electric engine with a genset more than diesel engines with a direct shaft and propeller.
Thank you. I didn't realize the complications that would come with a diesel engine and the traditional prop shaft drive. But it makes a lot of sense that the hull shape, especially towards the aft as it narrows, wouldn't leave room for such additions.
Yes, the point is that you have to have the engine, the form of the hull, the shape of the hull is a real performance shape. That means at the bottom of the ship it goes quite narrow at the end. So when you want to install a shaft, you have to have a very long shaft and to have the engines quite far in the front of the ship, not in the middle, but nearly at 1/3 of the end. So that means that you have a very long shaft and also a very long hole to put the shaft. So you have to put reinforcement in the carpentry work in order to do that. And in fact, it's very complicated, and you have lots of risk on a wooden boat to bend all the system. So that means you must do particular specific construction, carpentry construction to be sure that everything will stay straight. So that's quite complicated to install that, and quite expensive also, of course.
Right, and especially since this project was heavily fundraised, and it was just a lot of passion from people giving their time and volunteering. The money isn't really there to make such additions.
That's right. And there is also another reason which is important, is that finally the impact, the consequences of the installation of these engines and the propulsion, the power propulsion system is very light on the ship. I mean, we haven't transformed a lot the ship. We have just drilled a hole, and that's all, in fact. So that's also a real reason for the choice. One of the main points of this project is to have a very close to the historic a replica which is very close to the historic ship. So lots of decision has been made also in this direction.
Keeping the authenticity is important for a project like this.
Yes, that's right. That's completely right.
Are the electrical engine pods retractable at all? This question is from George Harkness.
No, they are not retractable. The pods, the pods, we can call them pods, are always in the water, and when the ship is sailing under sails, the propeller are turning, in fact, just naturally turning.
I'm sorry, I missed that last part. So you said the propeller will just free spin to not cause drag?
Sorry, I haven't received you.
The when the engines are not in use, will the propeller just spin to not have drag, and then the engine, the housing for that propeller is rotatable, correct?
Yes, that's right. That means that when you are under sails, the propeller are with the pressure on the propeller, with the speed, they are turning on their own, and with no control. That means they are just turning as far as the speed of the ship asks for them. I mean, with the pressure.
So I've just received note from the ship. They said that the satellite connection wasn't good enough for them to be able to connect with us. They are making about 125 to 150 nautical miles per day. So they're less than 2 weeks away from landing. They apologize for not being able to join us, and they ask you to continue to follow their journey and keep asking questions, which they will answer as soon as they can.
Okay.
So to everyone that is posting questions to me right now, if they're regarding specific action on the ship during the voyage, I'll write them all down at the end of the webinar and hopefully get them answered before they make landfall in Virginia. But if not, then as soon as I can contact the ship's crew.
Okay.
Laurent, did you have any involvement with the desalination machine on board?
Yes, of course, yes. We have been involved in all the construction of the ship.
Could you speak to how efficient it is, and is it able to keep up with the demands for fresh water that the ship has between the bathrooms and the cooking facilities, or is everyone strictly regimented to a certain amount of water?
Yes. In fact, one of the big difference between the Hermione of the 18th century and our new Hermione is that we can't live in the same conditions. So we need water. We need water for the kitchen. We need water to drink. We need water for the bathroom. So the amount of water all around that we need is around 4 tons per day. So we have on board, we have tanks for 3 days. That means 12 tons. Then we cannot cross the Atlantic only under the tanks. We have to produce fresh water with the water maker, and it's essential. I mean, you cannot live on board without those water maker. So that means that we have 2 water makers who are able to produce 500 liters per hour. So that means that they have to run around 8 hours both. We can also have only one working if one is out of order. That's why we have 2 water makers for the security. And so the idea is to refill the tanks of about regarding the consumption on board. So the consumption is 4 tons per day, and with 8 hours of working, the two water makers are producing the same things, 4 tons per day.
It's a very impressive system that they have, especially with the backup redundancy, which is very necessary should the first one fail. But I had no idea that it was such a large amount of water per day.
Yes, that's quite a lot, because you have 80 people living on board, so that means around 50 liters per person per guy, and in fact it's a very low consumption regarding what you are doing at home. But it's the consumption you cannot go. You have to it's a usual consumption on board, but it's much lower than what you have in a house. In a house, that would mean around 200 liters per day, and in a house, more usually you have 500 liters per day.
Wow, so they're still going without the normal amount of water that we would use on land.
Exactly. Everybody is sensible. The crew explain every day that everybody must be careful about the water. You are not having showers for hours and so on. I mean, everybody has to be careful about that. But even with that, it represents quite a big amount of water, of 5 tons per day, 4 tons per day. Sorry, that's quite a big amount of water you have to produce. And we have made a choice to have a quite a small tank because it takes lots of place and it's also lots of money to have much more than that. I mean, 12 tons, it's already big tanks.
Yeah, and there's a lot of other things to store on board, from the food to the people and all the equipment.
That's right.
Regarding the engines, do they make the new Hermione very maneuverable within docking procedure, or does the ship still require assistance to dock?
That adds a lot, because with the system we have installed, I haven't talked about that before, but we have a bonus comparatively to a direct shaft engine, which is that the pods can turn on their own. That means that you can change direction of the propeller, and you can directly push at 90 degrees from the boat, from the ship. So that means that you on the aft of the ship, it's very easy to maneuver. On the bow, it's a bit complicated. It's a bit more complicated. When as soon as you have a bit wind, you must have an assistance.
Do you think it will be common for the ship to come to dock, or is it more likely that it will stay moored or anchored a bit offshore due to its size?
You mean now or in 18th century?
Now, and I guess in the 18th century. I had been thinking about now, though, as it reaches the U.S.
Well, in fact, in the 18th century, this type of ship and all the ship, in fact, was always on anchor. They never dock because there were no dock, in fact, at this period. Just dock for small boats, but not for this side of ship. On our US tour, it's completely different because Hermione is a representative ship. The idea is to be visitable, to be seen by maximum of people. So it's a bit. The idea is not to be on an anchor. It's of course to be on a dock. So I have not all the information. But I think there is only one place that the ship will be on anchor. All the other places. And also in France, everywhere we go on dock.
That makes sense, given that we can now dock those very large cargo ships. There's definitely
right.
dock space for a boat the size of Hermione.
Yes, of course. For example, in La Rochelle here, in La Rochelle and Rochefort, in 18th century, there were no place to dock such a ship, and there were all moorings in the bay, in the bay of La Rochelle. So, but now, of course, we moor on dock.
We have a question about the lines being used on the Hermione. Are they made with modern materials, or are they made with the traditional methods and materials?
You think about all the riggings, all the running and standing rigging, perhaps no? What do you mean by lines? Yes.
Yep.
Yeah. So the point of Hermione, of the rebuilding of Hermione, was to, as I explained before, it was really to be as close as possible, as historical as possible. So we have worked a lot to see if we can do a full replica, especially on the riggings. And step by step, we have been convinced, and we have found the exact way, exact materials, exact treatment that were used in the 18th century. So that means that rope are completely traditional rope in hemp mainly, as well as for the standing ring, as well as for the running ring. We just have some modern ropes on very special purpose, which has there for security, because on natural fiber, it's quite difficult to have a security test and to be sure that you have a minimum safe load warranty. So that means that on specific rope, which were most important for the security, we have used synthetic modern ropes.
And for the sails, are the sails made from the traditional fabric, which I believe was linen, or are they more of a modern composite?
That's the same thing. We have also tried to the purpose was to do the best replica we can, and we have found an English and after that a French company who have been able to recreate a linen fabric of the right quality to be able to rebuild the sail in linen. So the sails are totally in linen, and the rope around the sails are in hemp, just as it was traditionally.
Just scrolling through the questions, how do they disguise the engine controls to keep the vessel looking historical in appearance, since those controls would have to be accessible from the cockpit?
Yes, so in fact on the Pont Gaillard, the upper deck, we have nearly nothing of no modern equipment apart two things. One is cleat for mooring on dock, which were not installed in the 18th century, and also one cupboard, in fact, which is after the helm station, and in which we have installed all the modern equipment for navigation. That means the engine controls, but also the modern equipment for the radar, for GPS, and so on. Communication as VHF and so on. So that's just a cupboard which is in aft of the M station, and that's all. It's all is grouped is in this cupboard.
Okay.
So that means when you are on board, just visiting the ship at the dock, the cupboard is closed and you can't see anything.
Okay. Well, that's a very smart idea.
Yes.
We have a question here from Robert Mills. He says the beam of Hermione is said to be 4.8 meters. Do the crosswinds cause the ship to list heavily away from the wind?
Sorry, I haven't received the question. Sorry.
The beam of the Hermione, it measures 4.8 meters. Does this width cause the boat to roll heavily with a crosswind?
What do you mean? Because the beam is 4.8 meters. That's right. What is I don't understand the correlation.
So if a wind is coming across the side of the ship, does it cause the ship to roll, or does she cut the wind fairly well?
There is two things in that. There is the stability point, and there is the sailing capacity. I think there is the two things. First of all, is the stability point. Hermione is a very healing very I can't find the word. Not a lot. It's very is healing very few. That means only 5-6 degrees when you have the wind on the side. So that's one point, and we have recreated exactly the stability of the 18th century ship. So that means the original ship was exactly in the same condition with the wind on this side. We have around 5 degrees of heel. That's the first point. Though it's a very stable ship. The first point. The second point is the I don't remember the word in English. Is when you are going sailing, is what you lost on the side. La dérive en français. I can't remember the word in English. I'm sorry. What appears is that Hermione, with all the sails we have done now, Hermione is a very good ship, and this is very low. Is very low also. So it's a very good ship, and you go very good in the wind. You don't lost. You lost very few degrees with that. I don't know if I'm clear, but
yeah, you've done great. We have time for one more question here. Do you know the Hermione's average speed under sail alone or with engine power, if needed?
The ship speed and our engine power is maximum. The normal ship, when you just go through low air condition, just to do miles, to be at the end at the at the appointment. I mean, it means that you have around 6 to 7 knots of speed. It's good. It's a normal ship speed, and you can go up to 9 knots under engines. Under sails, it's a much faster ship. You can go easily to 10 knots and also to 12, 13 knots. I was on board one sail between Brest and La Rochelle, so it's 200 miles, and we were during during a part of the time we are at between 12 and 13 knots all the time. So it's a very, very, very fast ship. In fact, I think it was probably one of the fastest fastest ship in the world at this period.
It sounds like it seems to still be an impressive speed for a ship of that size under sail. To be built in the times now. Though there are those racing yachts that do incredible speed, but for a ship of her shape, she seems to do very well.
Yes, I think I don't know if we will have a comparison with the tall ship in US in 2 days, but really I think that Hermione is probably very, very, very fast comparatively to all the tall ships which are at the moment sailing under the world. Yeah.
Well, that's all the time we have here. I'd like to thank you, Laurent, for joining me. It was great to have this time to talk with you, and thank you for answering all of the questions that have come up. You've shared a lot of great information with everyone today.
Sorry for my English. I'm not completely fluent, so thank you for your webinar.
I appreciate it. As I only speak English myself, it's been great to talk with you, and I think your English is incredible. So thank you again.
Thank you very much. Bye.
If you have not already done so, we invite you to leave us your contact info at cformation.com so we can keep you posted on future webinars. While there, please take a moment to thank the panelists who have made these webinars possible. From our website, you can also watch full recordings of the previous webinars if you have missed them or if you find yourself wanting to remind yourself of the answers that you've heard previously. On behalf of the crew aboard Hermione and the team supporting them in France and the United States, we want to thank you all for joining us. This is Ben Jensen for Mark Jensen aboard Hermione. Have a great day, everyone.